Hello, welcome to my video about efficient unit testing. In this video, we will see what a unit test is. We will see a first unit test and we will discuss the qualities of efficient unit tests. We will see the test code and how we can generally write better test code. I divided this course into 4 sections. In the first section, we'll talk about the basic. We will see what the unit test is. We will see unit testing, integration testing. Then we will write the first unit test using NUnit. We'll see what the good unit test naming is, the how to provide parameters to unit test. In the third module, we'll see what fakes are, mocks and stubs especially. And in the last module, in the fourth module, we'll see the qualities of efficient test code and how to write clean test code. Good. In the first part, we will see what testing is in general, and then we will see exactly what unit testing is. First of all, why do we need testing? Uh, so basically, if you know that your software is working, it's much more easier to deliver software. But if you know your stuff is not working or you're not sure, then it's a lot easier to not deliver software. So how to ensure that the deliver software is working? Actually, through testing. Good. We have two testing options. So we have the QA testing performed by QA team, so the software testers, and or we have this automated unit test, so the unit test written by developers. So QA department testing versus automated unit test. We'll see now the difference between those. Good. So the advantages of QA testers. So the advantages are the startup costs are very low, so they start immediately performing tests, exploratory testing on the UI mostly. So the UI code they test the UI much easier, yeah, and they can have in mind thinking of different things to test. The disadvantages of QA testing, it's much more time intensive, is not so efficient, and it could become frustrating. On the other hand, the automated unit tests, the advantages they are fast, they give us immediate feedback. Um, they are repeatable, you get a good code coverage, and they are fully automated. The disadvantages are that the time upfront is much higher. They are only as good as the developer skills who write them, and it's harder to test the user interface. Good. Wrapping up, what's the difference? So unit testing doesn't eliminate QA-related jobs. So instead of doing UI debugging by clicking buttons, the software tester will be able to focus on finding more logical application bugs in real-world scenarios through exploratory testing. Unit tests provide the first layer of defense against bugs, and QA work provides the second layer of defense, so the user acceptance layer. Allowing the QA process to focus on the larger issues will produce better applications in the end. Good. Now we'll see what is basically a unit test. So a unit test is a method that instantiates a small portion of our application and verifies its behavior independently from other parts. So the unit can be seen as a unit of work or a use case inside a system. When you test something, you refer to the thing you're testing as the system under test. So basically, you provide an input to the system under test and observe its output. If the output expects the criteria you're expecting, then the unit test will pass. And if not, the unit test will fail. So this will give you an indication if the system under test performs as you expected. Especially this unit of work is the sum of action that take place between the invocation of a public method usually and a single noticeable result by the test system. A unit can span a single method or multiple classes and functions to achieve an observable result. An end result is any of the following. It can return a value, a state, or an interaction. So the unit of work return values, as we see in this chart, is mostly return a value, a state, or interaction. So the invoked public method returns a value or a state uh, or behavior of the system before and after invocation. For example, if the system properties change, if the system is a state machine, we're checking that the state has changed, or there's an interaction with, for example, a third-party system over which the test has no control, and this third-party system does not return no value. For example, calling a third-party logging system that was not written by. We'll see in the next such an example when a logging is called. Good. Why would we test code? So we have the benefits, we improve the quality, we get immediate feedback, we have more error handling, it's much more easier to refactor if we have unit tests in place, and the side effect is that we in the end break the code into smaller chunks. It is much more modular. Now we'll see what the comparison between unit tests and integration tests. We see that in ideal case we should have more unit tests. So this is the takes a bigger part here in the testing pyramid. We have integration tests and we have the UI tests, which are basically performed by a QA department. We see that unit tests are fast and cheap, and as we go up in the testing pyramid, we see that the integration tests on one hand and the manual test performed by testing is slower, is much more expensive to perform. Integration tests basically use one or more real dependencies of the units under test. If the test uses the real system time, the file system, or a real database, it is basically an integration test. Integration tests are also important. There are important counterparts to unit tests, but they should be separated from them. I suggest to create a different project for them. Good. They have also some downsides. They take usually longer to execute than unit tests. They are hard to write and automate. It takes longer to understand by other team members. They need more configuration, harder to maintain, and the feedback loop takes longer because it takes longer to execute them. The purpose of the unit test in software engineering is to verify the behavior of relatively small pieces of software independent from other parts. On the other hand, integration tests demonstrate that different parts of a system work together, like in a real-world environment. They validate complex scenarios and usually requires external resources like databases, web servers to be present. So I would suggest to have a reasonable combination of unit and integration tests to ensure that every single unit works correctly, independent from other parts, and they work fine and plays nicely when integrated. Good. In the next slide, I will show you here a video about the difference between unit testing and integration tests. I found this on YouTube. I find it very funny. So basically, we have here the unit test, which actually works fine. And here you see why we need also integration tests. Okay, you see, we need also integration tests to tell to test the full functionality. Good. Next, we see some qualities of efficient unit tests. Yeah, they have to be clear and simple, easy to understand. They should provide a high value and should be flexible, so it's easier to fix them, to update them when the code functionality changes. Good. Next, we'll see what makes a good unit test. So, good unit tests are readable. They should be clear to all developers. If one unit test fails, it would be easier to detect how to address the problem. With good unit tests, we can fix bugs actually without actually debugging the code. They should be independent. They should not depend on other tests. One test should not set up condition for the next test. You should be able to run each test independently and run tests in any order you like. Also, unit tests should be fast. When they run slow, you won't want to run them frequently. If you don't run them frequently, you won't find problems early enough to fix them easily. They should be also professional. In the long run, you'll have as much test code as production code, maybe even more. Therefore, follow the same standard and good design for your test code. So this applies to unit tests as well as production code to have clean coding. Well-factored methods, classes with intention revealing names, no duplication, tests with good names, etc. Okay. You should have truly unit tests and not integration tests if you want to perform unit testing. Unit and integration tests have different purposes. Both the unit test and system under test should not access the network resource, database, and file system. Uh, so the structure of a unit test is, I suggest to follow this AAA pattern. Basically, this tells us that it contains three phases. So in the first phase, we have the arrange. So first, we initialize a small piece of application. It wants to test. Yeah, as we see, it's called also the system under test. Create objects, prepare inputs, and configure mocked interfaces. Then we act upon this system under test. We perform the actual work of the, which this basically performs the actual work of the test, typically by calling a function. Then, after calling this function, we assert, we verify that the unit under test did what we expected, did it return the right thing, or throw the correct exception. Ideally, this should only require writing a single assert. Um, Good. Unit tests should also have high precision. So basically, we should test one expectation per test. We can have multiple asserts on the same object. This is also okay, but not to not have multiple asserts on different objects. And unit tests should point us to the precise location of a problem. Good. Here we see an example. We see the high precision example as I mentioned earlier. So here we have a bad design. We have this test basically which asserts. You see, we assert against different results and different objects. This is not very good because it's not. If this test fails, we don't know what's exactly the problem with this method. So ideally, we should separate this test into three unit tests. You see, we have here clear naming with the AAA pattern, given, when, then. So the naming is very clear. It points us to the location of the problem in case such a unit test fails, and we test here against a single object. So it's clear that we separated this bad example into three clear unit tests. Good. In the next module, we will see the first unit test written in NUnit. We'll see good method naming, how to provide test parameters. We will see the setup and teardown methods and checking for expected exceptions. So we have here a system under test. For example, we have this class and we have this method which we want to check. So for example, this takes a string parameter, a file name, and we check if this is a valid zip file name. So if it ends with .zip, it's basically a good zip file name. If not, we return false. It's very basic example. Um, we create a unit test by adding these attributes. So with C# and NUnit, we have such attributes. We have this test fixture for the class, and for each method, we have to provide this test attribute. Yeah. We see here we follow the clear AAA pattern. So the range, act, assert is very clear each step. So here we we initialize these analyzers, the system, then we perform an action on the system under test. We call this method, and we assert the result. We assert that this is not a valid zip file name because .xyz is not a valid zip. Good. Test method naming. So for each unit of work, create a test method with the following name. So unit of work name, then the scenario, and then the expected behavior. So this is basically the unit of work name is the name of the method, basically, or group of methods or classes you're testing. Then we have the scenario, the condition under which the unit is tested, such as bad logging or invalid user, good password, and we have then the last part, the expected behavior, what we expect the tested method to do under the specified conditions. Good. We could also provide parameters to unit tests. So here you see we have also the test case attribute, but we provide here two parameters. We can provide them here in the test case class. We can give it as a constructor. We have here two parameters. This is a file and this is the expected results. And basically this is just one unit test, but when it's executed, it's basically three unit tests. So for each test case, we get these methods once as executed. We can also have setup and tear down methods. So setup and tear down methods are called before each unit test in that class. So you see, if we have here only a test method, we have basically two test methods, and for each of these test methods, the setup and tear down is executed before each of these unit tests. Okay, so to not duplicate code. You see, we have the setup, the method is executed, and then we call the tear down here down. Then for the next unit test, we call again the setup and the tear down. This is just one method to remove duplicated code, but I would suggest to avoid setup methods. Because the AAA pattern is violated using setup methods. Yet it may seem like a good idea, but soon it makes the tests below the setup methods harder to read. We can use instead the factory method to initialize the instances under tests. So the more you use setup, the less readable your test will be, because people will have to keep reading code into place. You have to skip to search for the setups to understand better the unit test. Um, and is not so intuitive. Setup method should only contain code that applies to all tests in the current test class, or the test will be harder to read and understand if not. So avoid setting up mocks and fakes objects within setup methods. Good. In the next, we have how to write unit tests and how to check for expected exceptions. So maybe you have a method which under some circumstances should throw an exception. So here we see we have the same method, and we add here a check. And if we do not provide a file name, we throw an argument exception. Okay. So this is the implementation, and we'll see how to test this. So we have the expected exception attribute, and this expects that the unauthorized access exception is thrown in case that we provide this input. Okay, and if we call this is authorized with this user context, then basically we expect that this exception is raised. Another way to catch this exception, to test for the expected exception, is you can use the assert catch, and here you provide a delegate. With assert catch, you got a nice separation of a range checked assert. You see, now we don't provide here the expected exception attribute, but we use the assert catch. So with this method, we have this arrange, act, and assert pattern nicely. So we assert here that this message is what we expected in this case. Okay, in the third module, we will see what fakes are, how to refactor your design to be more testable, how to use stubs, mocks, and fakes, and what are isolation mocking frameworks. Good. Normally in unit testing we have this problem, we have a strong dependency. So for example, here we will see we have this method we saw earlier, and this has a strong dependency on the logger. So the strong dependency we can see here basically happen when you use the new keyword and we create a new instance of the logger here directly. How we can solve that? We can basically get from this design, we introduce here a logger, iLogger, we have an interface, so we depend now on an abstraction, not on the concrete implementation. And for the unit test, we use a fake logger, and for the production code, we use the real logger, which maybe logs into a database. Um, Now we see what seams are. So seams are places in your code where you can plug in different functionality, usually using an interface. We can plug in a stub classes, adding a constructor parameter, adding a public settable property. With seams, we implement the open-close principle where the class functionality is open for extension, but the source code is closed for direct modification. Um, how we can use seams. So for example, here we see the constructor injection. So we provide here to the constructor this through this interface, iLogger interface. We provide an implementation, and we will see in case of unit tests, we provide here the fake implementation. In the real world scenario, we can provide here the real logger. Good. Fake objects. So if we want to provide a fake object which basically does nothing because we don't want to test this logging in this case, we just have to implement this interface, and this basically logs and does nothing. Yeah. Uh, Now we'll see what's the difference between stubs mocks. So basically these are both fakes. So in unit testing, if you need to replace actual external dependency with placeholder fakes, so you can control various scenarios and validate your code does what you expect to do. Both stubs and mocks fake the behavior of external dependency, so you can say that you are creating fakes when you are faking an external dependency. So fake is a generic term that can be used to describe either stub or mock because they both look like the real object. Whether a fake is a stub or mock depends on how it's used in the current test. If it's used to check an interaction, so you assert against this fake, it's a mock object. Otherwise, it's a stub. We see here so the stub is a controllable replacement for an existing dependency in the system. We have here the class under test. We have this uses a stub, and in the end the test asserts against the class under test, not against the stub. Yeah. So a stub can substitute for external dependency to either just pass by, do nothing, or return some specific data for the scenario you are testing. The stub, importantly, cannot directly make a test fail. In comparison, a mock object decides whether the unit test has passed or failed. There's usually no more than one mock per test. You see, here we have the class under test, we have the abstract interface, the iLogger, and the test asserts not against the class under test, so it asserts against the mock object. So this is used for interaction testing where we cannot check a value. Uh, so the basic difference between mocks and fakes is that stubs can't fail tests, mocks can fail. The test will use a mock object to verify whether or not the test has failed. Mocks are just like stubs, but you assert against the mock object, whereas you do not assert against a stub. Good. In this section, we'll see how to create a mock. So basically, we create here a handwritten class which implements this iLogger interface. It's the same like a stub, but it saves some state for later. So for example, we have internally here, we have a logged messages list, which we are extending as we're logging messages. Yeah. So this is not a mock object yet. It will only become a mock object when we use it as one in our test. Here we see how this fake logger is used in our test method. So the assert is performed now against the mock object and not against the analyzer and the result of this analyzer class method. Um, that's because now we're testing the interaction between zip file analyzer and the web logger. It's perfectly okay to have multiple stubs in a single test, but more than a single mock can mean trouble because you're testing more than one thing. Um, we have this rule, one mock per test. In a test where you test only one thing, there should be no more than one mock object. All other fake objects will act as stubs. So having more than one mock object per test usually means you're testing more than one thing, and this can lead to complicated or brittle tests. You can have multiple stubs in a test because a class may have multiple dependency like the iLogger we saw earlier, and just make sure that your tests remain readable. Good. Here we see what isolation mocking frameworks are. So a mocking framework, isolation framework is a set of programmable APIs that make creating fake object much easier, faster, and shorter than hand coding them. So isolation frameworks, when designed well, can save the developer from the need to write a lot of repetitive code, as we saw earlier, to assert or simulate object interactions. With isolation frameworks, you use them instead of writing mocks and stubs manually. It has several advantages and makes development of coding much more easier, faster, and less error prone. So for example, we have here the mockq, isolation frameworks, or Rhino mocks in .NET. Uh, Good. Dynamic fakes. So dynamic fake object is any stub or mock that's created at runtime without needing to use handwritten hard-coded implementation of that object. We see we use here the mock. It's this isolation framework. It's much more easier. We have some setup methods. We don't have to create our own fake object. We just use this API. We can set up things to return in certain circumstances. Here an overview of mostly used mocking frameworks in .NET. We have the mockq framework, the Rhino mocks. We can also write our own fake implementation, fake it easy, and substitute. There are a lot of them. Good. So some more details. So we should avoid mock objects if you can. Tests will be always more readable and maintainable when you don't assert that an object was called. These are implementation details. Yes, there are times when you can use only mock object, but that shouldn't happen often. Prefer testing behavior, not implementation. Your test should assume as little as possible about internal implementation details. Instead, multiple stubs can be used for external dependencies, as we saw earlier. Good. In the last part, we will see qualities of efficient unit testing. So the test code, basically, we should provide clean test code. We should write trustworthy tests, maintainable and readable tests. Okay, we'll see now how to do that. Here I like this quote for Martin Fowler a lot. So any fool can write code that a computer can understand. Good programmers write code that humans can understand. So this applies to production code and also to test code. So apply to unit testing. Any fool can write a test that helps them today, and good programmers write tests that help the entire team in the future. So qualities of clean test coding. Unit tests are important as production. Source code follows same clean code design principle. So what makes tests readable? The same thing that makes all code readable: clarity, simplicity, and density of expression. In a test, you want to say a lot with a few expressions as possible, like in production code. We should follow the same solid design principles: single responsibility, open for extension, closed for modification, list of substitution principle, the dependency inversion, and interface segregation principle. And applied to unit tests, the single responsibility means that a class should have one and only one reason to change. A class should only do one thing, keep things clean and organized. Related to dependency inversion principle, dependency between chunks of code should always be modeled as abstractions. So we saw this using interfaces. So use interface rather than concrete types for dependencies. Good, we have this, I would say, the three pillars of good unit tests. So writing trustworthy tests, writing maintainable tests, and writing readable tests. Trustworthy tests don't have bugs and they test the right things. We should avoid logic in test and test only one concern: a return value, a change to system state, or a call to a third-party object. This is used by using mocks. Yeah, we should separate unit from integration tests, and we should also have code reviews for unit tests as well as production code. Maintainability. uh, we should test only again public contracts, remove duplication, enforcing test isolation, avoid multiple asserts of different concerns, basically on different objects. So developers will simply stop maintaining and fixing tests that take too long to change or that need to change very often on minor production code changes. Readability applies for unit tests as well as production code. This means not just being able to read the test, but also figuring out the problem if the test seems to be wrong. Naming unit tests and variables is also very important. So here we see again this naming convention, the three-part naming. It should have three parts: the name of the method being tested, easily see where the tested logic is, the scenario under which is being tested, and the expected behavior. This part specify how it should behave based on the current scenario. So we have this given when then pattern. For example, here is our example: user login. This is the given part. When we provide valid credential, then the result redirects us to home. So these are just some basic examples. Good. We should design code for testability, and testability can influence the design of our software in various ways, mostly for the better. If we're doing TDD, so test-driven development, you'd have no choice but to write a testable system, because TDD, the test comes first and largely determine the API design of the system. Here are some tips for testable code: is to add seams. So this place is where you can basically inject the external dependency through seams in constructor injection, for example. Avoid the new keyword because this creates a strong dependency. Beware of static methods, they are harder to test. Uh, we should favor composition over inheritance. Avoid mutable global state because global state is hard to test. And avoid constructors that do logic. The logic should be mostly into the method. Okay, one further note on this setup and teardown methods: I would suggest to avoid these methods. So setup and teardown methods in unit tests can be abused to the point where the test or the setup and teardown methods are unreadable. If you have mocks and stubs being set up in a setup method, that means they don't get set up in the actual test, and in turn means that whoever is reading your test may not even realize that there are mock objects in use or what expectations from them are in the test. Yeah, it's much more readable to initialize mock object directly in the test itself with all their expectation. If you're worried about readability, you can refactor the creation of the mocks into a helper method with which each test calls. That way, whoever is reading the test will know exactly what's being set up instead of having to look in multiple places. Uh, okay, so this was it. I hope you enjoyed it. So for the resources, I used a lot this book by unit testing with examples in C Sharp by Roy Oshrove, and also I suggest this clean coding by Robert Martin. So thanks for watching and see you in the next videos.